Here we're going to look at our simulation of waves on a string and go through those four choices, those four possibilities we just saw in the notes. The first one is written down here. Here's our wave equation. If we hold the frequency constant, and we will do that by not changing this. We won't change the frequency, so this up and down motion will always be at the same frequency. We hold that constant, but we increase the speed. What will happen to the wavelength? And you can look at this and think and predict it for yourself. How do we increase the speed? Well, if you remember what I said in the notes, we increase the tension in a string or spring and the speed will increase. So first let's get an idea of the speed here. Move the cursor along with it. So get an idea of the speed. You can move your finger along with it and get an idea of the wavelength. The wavelength here, it looks to be about 2 centimeters from 3 to 5 there, a little less than 2 centimeters. All right, so now let's increase the speed. So we're holding the frequency constant, that's this, and we're increasing the speed by increasing the tension. The wavelength was 2 centimeters. Now let's see what happens. So we'll increase the speed. First, let's verify the speed increased. Move your finger along. You have to move it faster now than you did before. And then let's look at the wavelength. All right, the wavelength has changed. It was about 2 centimeters. Now it's 3. So if we have the frequency constant but we increase the speed, then the wavelength increases. All right, let's try the reverse. Let's set this back to what it was before. Let everything get to be. Now here we're holding the frequency constant. We're looking at the speed. Here's, move your cursor along, move your finger along with it. I'm moving the cursor and you can get a feel for the speed. And now we're going to reduce the speed by lowering the tension. And you should predict what happens to the wavelength. And we'll change this here. What if you decrease the speed? Look at this equation. You make this smaller. You keep this, f, constant. What should happen to the wavelength? All right, so let's do that. Let's decrease the speed. Right now the wavelength is at 2 centimeters again. Let's decrease the speed and see what happens. All right, and you can see the change occurring over here. We'll let that change move. So let's see if the speed really is slower. Let's follow a crest. Oh yes, that's much slower. See how much more slowly you have to move your finger along with the crest. And now let's pause it and look at the wavelength. You can see the wavelength here from crest to crest is significantly less than it was before. It was 2 centimeters before. Now it's less than 1 centimeter. So the answer to the question is just what we predicted in the notes. If the frequency is constant, but the speed goes down, right? This stays constant. This stays constant. We lower the left side. To keep this in balance, you have to lower something on the right side. And the only thing that's changeable in this example is wavelength. All right, now we're going to look at the case. All right, sorry, I had to fix something. Now we look at the case where we hold the speed constant. And these two can change. Frequency and wavelength can change. And we'll look at the first case where we hold the speed constant and we increase the frequency. All right, so let's get things back to normal here. And let this propagate through, get a feel for that speed. All right, now we're going to hold the speed constant. So we will never touch this tension bar. The speed will stay constant. And we're going to increase the frequency with this slider bar here. So let's do that. And what you'll see is you'll see this move up and down more quickly. So again, our wavelength is at roughly 2 centimeters. Now let's increase the frequency. This is moving up and down more quickly. Right? And the wavelength has changed. It's gone from about 2 centimeters to a little more than 1. So the wavelength has gotten smaller. So what we saw there, if we held the speed constant, if you make this bigger, f bigger, to keep things in balance, lambda, the wavelength has to get smaller. So your answer here would be decrease. All right, now let's try the final example. Final case, and that's of course if we decrease the frequency, what should happen to the wavelength? And you can probably predict what's going to happen. All right, so let's set things back to the way they were. Frequency of about 2. Let this propagate through. All right, now remember what we're doing is we're holding the speed constant, so the speed of these crests will stay the same. But what we're going to do now is lower the frequency with this bar, and so this will move up and down more slowly. So we'll lower that down to just like a half a hertz. All right, and you can see that wavelength has gotten much longer, much increased. From here to here is almost 4 centimeters, and that's only half a wave. That's from a crest to a trough. So the full wavelength, instead of 2, has now gone up to almost 8 centimeters. All right, so the answer to this last one is if we hold the speed constant and we make the f smaller to compensate, the lambda or wavelength has to increase, has to get bigger.